Hey everybody, we are going to get started with Unit 2, Lesson 1. And to start off this video, I'm actually going to have you try example 1 on your own. So it says find the sine, cosine, and tangent values for angles A and B in the triangle below. So why don't you go ahead and write out sine A, cosine A, tangent A, and the same for B. And I'd like you to pause the video and figure out these values on your own using this triangle here. So pause the video. When you're done, restart the video and I'll have the answers here for you to check in a minute. All right, check over your work and see how you did here. Hopefully you use the Pythagorean theorem to find the missing side length, which gives us the square root of 33. And then we go through and do our SOHCAHTOA. Tangent B, remember you're going to have to rationalize the denominator. We can't leave it as 4 over the square root of 33. We would change it into 4 square roots of 33 over 33. Now, this brings us to something that I want you to notice. And maybe you've noticed this before, but what I want you to realize is that the sine of A is equal to the cosine of B. And the cosine of A is equal to the sine of B. And that is because sine and cosine are co-functions. Sine and cosine are co-functions. And there are other pairs of co-functions as well that we'll go through here in a minute. Now, let's talk about the relationship between angle A and angle B. We don't know the exact measurement of those angles, but what we do know is that angle A and angle B are complementary. They add to 90 degrees. And we know that because angle C is 90 degrees, which means the other two must add to 90 degrees. So it will always be the case that the sine of one angle will be equal to the cosine of the other and vice versa. So this brings us to our cofunction. If I have the sine of theta, that means that the cosine of 90 minus theta is equal to it. Now, why 90 minus theta? Well, it's 90 minus theta because they would be complementary to each other. The complement of theta is 90 minus theta. Same thing here, cosine theta. Cosine theta is equal to the sine of 90 minus theta. Now, what are our other pairs of cofunctions? Well, if sine and cosine go together, that means secant and cosecant go together. Tangent and cotangent go together. So cosecant theta is equal to the secant of 90 minus theta. Secant theta is equal to the cosecant of 90 minus theta. So these two pair up, these two pair up, and these two pair up. Tangent theta is equal to the cotangent of 90 minus theta. Cotangent theta is equal to the tangent of 90 minus theta. Now, I know that's a lot of 90s and thetas, but hopefully it'll make a little more sense when we look at it in some of these examples here. Write each function in terms of its cofunction. So let's think about an expression that would be equivalent to the cosine of 52. Well, the cofunction with cosine is sine. And what's the complement of 52? I'm going to do 90 minus 52, which is 38. So cosine 52 is equal to the sine of 38. So just to confirm for you, cosine 52 and sine 38 do give us the same value. And this goes back to our original triangle up here. Imagine that angle A was 52 degrees. That would mean angle B has to be 38 degrees. And we know that the sine and cosine of those angles are equal to each other. All right, let's try part B. Tangent 71. Well, what's the cofunction? Cotangent. And I'm going to do 90 minus 71. So we have cotangent 19. Secant 24. What is the cofunction? It's cosecant. 90 minus 24 gives me 66 degrees. Okay. Find one solution for each equation. Assume all angles involved are acute angles. So we are told that the sine of theta is equal to the cosine of 35. Well, sine and cosine are co-functions, and if these are equal, that means that the two angles must be complementary. They must add to 90. So theta plus 35 must equal 90, which means that theta is 55. So let's see if that makes sense. Would sine 55 equal cosine 35? Yes, because they add to 90, just like we found up here with these ones. We're going to do the same thing. In order for the tangent of 63 to be equal to the cotangent of theta plus 15, these two values would have to add to 90. And then I solve theta plus, what is that, 78? Theta equals 12. Again, same thing. Cosecant and secant are cofunctions, which means 2 theta plus 4 theta equals 90. So theta equals 15. Now, one mistake that I see students do all the time is what they want to do is just say, oh, 63 equals theta plus 15. No, these are not equal to each other. They are complementary. They're going to add to 90 degrees. So what I'd like you to do is pause the video and try the other part B's, this part B and that part B, on your own. Set it up, solve for theta, and then check back with the video to see how you did. All right, hopefully you were able to set up these equations where the two angle measures are complementary. I got theta equals 21 and 30. All right, so here I have three angles that are increasing in measure. We have a small, medium, and bigger measure of theta. And we are going to turn these into triangles. So we're going to draw these lines straight down. Now, I want you to imagine that these are on the coordinate plane. So these are my x and y distances. And it might be hard to tell, but I made it so that the r value is constant on all three triangles. The hypotenuse is the same every single time. So what is happening to our sine values as theta increases, and what is happening to our cosine values as theta increases? So one thing to remember is that sine is opposite over hypotenuse, or y over r in this case. Cosine is adjacent over hypotenuse, or x over r. So as theta gets bigger, r stays constant every time, but what happens to my y value? My y value gets bigger. So as theta increases, sine theta increases. Let's talk about cosine. Cosine is x over r. And again, r is constant. So what's happening to x? This distance, the adjacent leg, is getting smaller and smaller every time. So as theta increases, cosine theta decreases. So we're going to take this idea into our last couple examples that we're going to talk about. Tell whether each statement is true or false. Sine 21 is greater than sine 18. Well, we know that as the angles increase, so does sine. So the bigger the angle, the bigger the sine, and this would be true. Cosine 49 is less than cosine 56. So as theta increases, cosine decreases. So actually the bigger angle would have the smaller cosine. So this is false. All right, we are going to pick up right here with special right triangles when you come back to class next time.